So we are still in the world of determinants, and you're trying to figure out how to get to find the determinant of a matrix in different ways. Okay, so in this particular video, what I'm going to do is going to go through how to use row operation methods to find the determinant of a matrix. And this kind of row operation method is going to be quite a bit off from the one I've already taught. I mean, the normal row operation. This one I'm going to use what we call Gaussian elimination with partial pivoting. And I can tell you for a fact that when you're done with that, together with properties of determinants, the determinants of that new matrix you get will be the same as what you have here. The problem is, why do you want to use row operations to find a determinant? Because row operations will reduce the matrix to a triangular matrix, right? And we know how to find a determinant of a triangular matrix by just multiplying the diagonal entries. Okay, so to start with, I'm going to start with what we call Gaussian elimination here with partial pivoting. So what do I mean by that? So let's start. To reduce this matrix, I'm going to switch row 1 and 2. And remember, properties of matrix is saying that if I form a matrix by switching the rows and or maybe some particular rows and columns of the original matrix, then the determinant of that new matrix you get is negative of the determinant of the original matrix. So because we did this, because we switched rows in A, whatever matrix we get here, its determinant is equal to, so maybe if I call this new matrix B, then the determinant of A should be equal to negative times the determinant of B, right? So what I mean is that whatever results we get for the reduction of B after everything, suppose maybe we didn't switch any other row, then the determinant we get, we have to multiply by negative to get a determinant of A, right? From the properties of determinants. So that should be in your mind. So the partial pivoting is saying that, I mean, that was the main reason I straight that. You go through the whole of these rows, and then the entries here will have 0, 2, 3, and 2. The one with the highest magnitude, you make it become the pivot. So you straight that row with the first row and then make it become the pivot. And here 3 has the highest magnitude, right? So I straight that with row 1 and 2. Now once you have this, then how you do this is that you're going to write you're going to transform your matrix in this form. But I know this guy is 0 already, so I don't do anything to that. So what I'm going to do is I'm going to reduce this guy to 0. But partial pivoting, the factor I'm going to use is row 3 minus this value you have here, which is 2, divided by that value you have there, that is 3, times row 1. And when you do this, that part is going to go to 0. So you can try that. So this new matrix that we formed will be transformed into this form. I mean, there's also partial Gaussian elimination, right? But there's a special way as Gaussian elimination with partial pivoting. 0, 1, 5, and then if you do that, row 3, you have 2 here minus 2 over 3 times row 1, and that element there is 3. So this will take that, and I'm going to get 0 here. I mean, if you do for all the entries, corresponding entries, that's 6 and negative 6, 1 and 9. Okay, you're going to get this to reduce to 10 here and then negative 5. Right? So that is what you have. So we have our new matrix being reduced. Remember, we switch rows, but the new matrix has reduced to this 0, 1, 5, 0, 10, and negative 5, right? So what we're going to do here in this is go ahead and then look at the next thing to do. The next thing to do is to reduce this guy here below the 1 to 0. But before that, we are still using partial pivoting rule here. So I have to compare these two. The one with the highest magnitude. When I say highest magnitude, I mean the absolute of 1 is 1. The absolute value of 10 is 10. So the one with the highest magnitude, that's what. So if 10 was negative, I would have picked 10 because the absolute of negative 10 is 10, which is bigger than the absolute of 1, right? So I have this. So I have to switch row 2 and 3 because of the partial pivot. I have to make sure that the pivot has the highest magnitude compared to the next row. And in that case, I'm going to have 3, negative 6, 9, 0 here, and then 10, negative 5. Remember, I'm switching rows, right? And this guy. So this, then I have to reduce beneath this 10 to 0. And to do that, I'm going to do row 3 minus 1 over, like I said, this guy divided by the other guy, right? So 1 over 10 row 2. And if you do that, this, remember, we also switch this row, right? So after switching it, we have a different matrix from our original matrix B that we were dealing with. So whatever determinant we get for this matrix here, the determinant of this guy should be the negation of what we will get, right? So let's try to finish with the row operations, and then I'm gonna show what I was talking about. Negative 5, 0, and if I do that, so row 3, the first entry there is going to be 1 minus 1 over 10 times 10, right? And that this is going to give you 1 minus 1, which is 0. If you do for the other one, you're going to get 11 over 2. So, like I said, if you look at this matrix here, it is an old matrix which was A, 0, 1, 5, 3, negative 6, 9, 2, 6, 1, right? That we've reduced, gone through processes to get back to this one. Now the determinant of this reduced matrix here, let's say I'm calling this matrix maybe matrix C. Determinant of C is equal to 3 times 10 times 11 over 2. And the reason we go through this whole thing is because we want to get, which is 165, because we want to get an upper triangular matrix or maybe a triangular matrix, and then multiply the rows or the diagonal entries to get our determinants. Okay, so that is it. Now if you look at matrix, the reduced matrix C, it was given from the matrix B, and B was given as 3. The reduced form of B was 3, negative 6, 9, 0, 1, 5, 0, 10, negative 5. So this was maybe the reduced form of B. And before we reduced B to C, we switched it. So it means that the determinant of the matrix B is equal to the negative of the determinant of C, which is 165. And then before we go to the matrix B, we switch matrix A, right? We switch rows in matrix A. So the determinant of matrix A, which is what we are looking for, is negative of the determinant of B, which is negative 165, and that is 165. So in general, if you are reducing a matrix using this Gaussian elimination with partial pivoting, and then you switch rows 2 times, then right after everything, your determinant, you have to multiply it by negative 1 to the power 2. If you switch it maybe 3 times, if that maybe we're dealing with a 4x4 matrix, and we did the switching 3 times, then we'll multiply our final determinant by negative 1 to the power 3. Right? And this is a result of the properties of determinants. Now the determinant of this reduced matrix has magnitude 165, and that of the A is also having 165. So the determinant of that matrix given in the problem here, the determinant of A is 165. Alright, so I mean that's how you use row reduction to find a determinant of matrix. So in the next lesson, we're going to talk about something different in determinants, and stay tuned as we dive more into the world of matrices to figure out what we can do with matrices. Right, see you